So welcome. I hope you all had a nice lunch. Thank you for having me in this beautiful city. I have never been there, even though I have been living in Switzerland now for 1.5 years. Um, my name is Paco from Beckhoven. I am a software engineer at Hexagon. Let me start again. So, after working for many years as a consultant, I moved to Switzerland to start a new life, enjoy new things, and I joined Hexagon. I work at the innovation hub of Hexagon on a product called HXDR. It's an online cloud platform for 3D visualization, and specifically you can explore and edit really large model and enrich them, 3D models, and that also includes all the 3D models that come from the scanners that we build. But you can forget that part now. The most important part I would say is I really like code quality. I like to talk about code quality. I like to talk about developer experience, and that's also why I'm here to hopefully teach you a thing or two. And that's also enough about me. Yeah, let's talk business. So, $316 billion, not my salary unfortunately, was the estimated cost of fixing bugs in 2013. Now, this research was done by the Cambridge University and was done by a couple of students. Now, you can imagine 2013, we're now in 2025 already. This probably has increased so much that we can solve a couple of world problems. But unfortunately, this is the money that we waste on finding and fixing bugs every year. And now, what can we as developers do about this? How can we improve this? So one of the things that's known is that the longer it takes to find a bug, the more money it costs to fix a bug. If you find it in the requirements phase, it's free because you don't waste development. But if you find it when it's already running in development for a time and people don't know about the feature they developed, it becomes much more expensive to fix it. Now, there are many ways to spot bugs early, infinite ways, but for this presentation, we're talking about code reviews. We'll mostly be focusing on code reviews, which take place approximately in the coding and testing phase. Now, next question is, what is a code review? So I found this nice definition, and I sort of split it into 3 parts. What I really like, so the first part is finding and fixing bugs. So it's, the thing we just mentioned, we need to decrease the bugs we have to save a lot of money, but it also saves a lot of frustration and also reputation. But there's more to it. It's also about fostering learning. Like the code reviews are a great place to learn from each other and to also teach each other. If somebody is new, you can learn them about new company standards or best practices, mentor each other. And then there's also the last one, improving code quality. So I added a simple definition of code quality. Of course, there's, again, many out there, but in general, I would say it's about making the code more readable. There's, by the way, more seats in front if you want seats. More readable, more efficient, and in line with a company's with a company's conventions or the best practices that you have within a certain team. Now, this all sounds pretty great, right? Code reviews? Yes? Oh, awesome. So I don't want to see this. Now, because I know it was a bit of a bold statement, I added a bit of nuance. Because yes, this does not always apply. There's always reasons why you maybe don't want to do code reviews. For example, if you heavily invest in pair programming or mob programming, or you have a very senior team which is very experienced, have been working together for each other for a long time, you might go into the deploy first, review later, sort of to ask for forgiveness rather than permission. But again, for the sake of this presentation, we're going to talk about why we should be doing code reviews, which I think for most of teams is part of our regular day-to-day process. Now, how do we incorporate these practices? How do we incorporate these code reviews into our development practices? And this is what we commonly do through pull requests. So we create a new branch, we put our features, our changes on the branch, and then we sort of ask if we can merge it to the master branch or develop branch or whatever branch you use. Now, I want to do a quick show of hands. Is it pull request or merge request? So pull request, merge request. Right, so usually these are the GitLab users, because indeed there is one tool out of these that is pushing merge requests. I also work for a company that uses GitLab. I also had to get used to merge request again. So if I intertwine the terms in this presentation, I still mean the same thing. They are the same thing. No need to have a discussion about it, but then you know why I can sometimes mix them up. So GitLab or GitHub or many of the other tools, they are great tools, version control systems that help us facilitate this code review process. There's you can add commands, you can add suggestions, there's tools that integrate with it, which make sort of the whole process possible. So the technical factor is already sort of taken care of, but there's still some problems, and that's mostly, I would say, the human factor. So to give you some illustration of the things you could encounter, you have the pull request that is very descriptive, but still in the meantime changed 55 files, and yeah, good luck. Also, it gets looks good to me in 30 minutes usually, because why bother? Yeah, there's the great feedback that we get from people, not always as great as we hope it would be, or the fact that people are not really inclined to review because I don't like it. And last but not least is the curse of the small pull request, where the smaller it is, the more traction it receives, and the longer it takes, longer than the 55 file one. It's always a surprise to me. Now, how are we going to address this issue? So in this presentation, we're going to take you through some parts, and I want to start with creating review-friendly pull requests. This is the first thing that we can do as a developer when we create a pull request. For this, I'm going to assume that all the things we did up to now we're done according to the book, or changed or concise, focused and tested, even though in practice this is usually not the case always, but let's say for the sake of it, we covered the development part. Now before I continue, I also wanted to quickly cover this quote by Robert C. Martin, also known as Uncle Bob, which basically says that we spend way more time reading code than we spend time on writing code. And this actually goes further than just code. This, I think, goes for pretty much anything, right? When you create a pull request, the description of this pull request is you only write it once, but it's going to be read by every reviewer, including future you, because you forgot about this thing and somebody's asking you questions about it. It also goes for Slack. If you send out a message in a group or a channel and you want to get some feedback, again, you write once, you read many times, which is also why we should put in effort to write it nicely. So I want to start with a title. Now, a good title should be as good as a good commit message. It should be self-explanatory, and it should work. So fix bug is usually not a good title. You want to add some context. In this case, say we have different devices. This is about, say, a mobile app. We have iOS, we have Android. We want to add some context, also maybe when the bug is occurring. That's already much easier to sort of quickly identify what this pull request is about. And the other thing is, what you often see, is that the title of a pull request also makes its way as the commit message. And it also often ends up in the release notes if it's also in the commit message, because we squash. So why not take it a step further? And actually, like I said, it's like a good commit message. Why don't we apply the same linting that we have for commit messages that you can have? So if you don't know conventionalcommits.org, it's a great way to sort of standardize the way you write commit messages, which is really nice because it's also nice. In the end, it also standardizes your release notes because you want them to be consistent, the way you write them, the tone, the verbs. So we can also apply this to the pull request titles, and we can even lint it. We in our own company, we fail the build if the pull request doesn't fit the linting. One of the things that it, for example, suggests is to use the prefixes for fixes or features or patches, or when it's a major or minor release. You can even imply the versioning from the pull request title. Also make sure to include like a reference to the ticket. I mean, it's sort of logical, but refer your ticket management system, and usually most VCS tools automatically link them. Now that's a title, just a title. Then there's also description, right? There we can put a lot of information, and we want to start with the context, like it's sort of an extension of the title, and here we want to add anything that the person who writes the code should read the review. The reviewer should know. Maybe it's different tickets, maybe it's some documentation, maybe it's something to set the scene. Then you want to take it a step further. You want to talk about what you changed. You want to give a brief overview of what the reviewer can expect, because even though we just said our changes are concise, often we also maybe the tiny refactoring over there, or maybe we fix some things over here, just to give you an overview of what's going to happen so that people can also quickly identify things that maybe were not intentional. The why, I always find that a nice one that's forgotten is when you write, you may make changes. You go through this thought process. You try different things possibly. Maybe you try different frameworks, maybe different algorithms. That knowledge is usually in your head, and it sort of stays in your head until the weekend. And it's also important information for the reviewer, because the reviewer might be interested in why did you choose a certain approach. So whenever you have some knowledge in your head that things you considered, just write them down in the pull request. Even if and then this should be the last resort, because if it's a big thing you considered, maybe you need it to be documented on Confluence somewhere on these architecture decision records. There's many places to document this, but if not everywhere, then at least do it in the pull request as close to the change as possible. And then We can also add some examples. This is also something that makes the life of a reviewer a lot easier. And for the front-end code development, this is sort of obvious, right? You can add screenshots of the new screen and the old screen. But you can also, for back-end development, if you're writing an endpoint, you can add some example requests, because you were probably testing it yourself as well. So you already wrote this request, you already tested it, you have example responses. Paste them in there so that the reviewer also can easily, they don't have to write a request from scratch. And the other nice thing is that you sometimes can quickly identify issues if you actually see the response rather than that you have to look at the code. But also for databases, if you change the database structure, you can just, well, at least paste some example queries and some example results or things you do there. And now last but not least, the challenge is to keep it concise and readable, because nobody likes the wall of text and some people also don't read a wall of text. Now this is something that you can do at sections, or simply ChatGPT is actually quite helpful in this part at least, where it can sort of make the text more readable. But what can also help is just use templates. So in most VCS tools you can set up templates with different sections, and the nice thing is that people, when it's consistently structured, people also know quicker and get used to where to find the right information. And what I specifically want to emphasize here is checklists. It's a really powerful tool that we often forget about that it actually exists. But within each pull request template, you can also add a number of things or tasks that should be completed. Say, for example, the architecture diagrams. Like if you have them, say, and they need to be updated every now and then. This is usually only 1 out of every 10, maybe 15 pull requests, because we're also fixing bugs and those really require change to documentation. We forget about this part of the process, or maybe there are some release notes, things of processes that were not automated. Or what I particularly also like is the first one, changes are covered by tests. And it seems so obvious, but it's still a great reminder that if you create this pull request, you have to check this box. So if you took a shortcut before, you're now reminded of the fact that did I do it? Or I'm gonna lie here. It's a bit of a, make people aware of the things that they're doing. Now, we created this review-friendly pull request, and the first thing we want to do now is review it ourselves. Why not look at a pull request now? And the reason why is that if you review your own code, you sort of get a different perspective on your changes. Let it be just the fact that all your changes are now summarized in just simple diffs. And this allows you also to add a lot of comments. Start commenting on your own pull request as if you're your own reviewer. And maybe if there's things that are out of the ordinary, which you think, hey, right, I refactored this, it's not part of the logical flow, I'll just add a comment, I refactored this because of this. And because it's a question that you could get. If you add it yourself proactively, then it's much easier for the reviewer and they don't need to ask questions. But also if you did some research. So in this case, I removed a file that was unused, and I was curious why the file was unused, since what shouldn't have been removed earlier. So I tried to go in the history and saw, oh right, it should have been removed as part of this pull request. If I link it here, then at least the next reviewer, which might also be curious, doesn't have to do this research as well. So basically all the things you do, just document them, and then it's much easier for the person reviewing it, they don't have to go through the same effort. What you can also do is add comments to highlight important parts. So what can happen is that there's a big class and it hasn't been formatted in a while. So you sort of click the formatting button, but you also fix the bug, which was a 1-line change. You have 60 lines changed in your file. Just add a comment to that 1 line that is actually the bug fix to quickly highlight it to the reviewer. Like, this is the important part, the rest is formatting, not really relevant. And what I also sometimes do is it's a nice place to also ask questions. If you're unsure about a certain part, or if you have doubts, or maybe you're integrating with another team. So there's another team in your company that's built a certain library, you're not going to use it, you want maybe some tips or tricks. You can tag them directly there so that they immediately know within the right context what they could improve. Okay, so we sort of were the first commenter as well. Let's ask for reviews. Reality is often that it takes a long time. You throw a message into a void and sometimes people are actually responding. In an ideal world, of course, people proactively check the pull requests and see if there's something new and they start actively reviewing, or you round robin assign them in your VCS system, like, okay, now you review this so that it's assigned. Well, in practice, not so much. So why does it usually not work? I think the first reason is this thing called diffusion of responsibility. So it's a task that people are not really inclined to do because it takes them away from the current context, or maybe they deliver now slower because they're spending time on different things, or they think they can't find of anything. Instead, and then you throw a message sort of into this void of people that actually don't want to do the task. So what happens? Everybody sort of assumes that somebody else will look at it because I already did one this week. To counter this, tag specific people, tag a specific team, make your message specifically targeted to somebody. And if you target the wrong person, you'll see soon enough that they know to point you to somebody else if they don't want to do it. So you end up with the right person quicker, and they feel responsible, so there's more likely that they're actually going to do something. What it can also help is to add some context. What was the change? You can dump a pull request link, but I mean, what is it about? Because if somebody might be working in the same area, or maybe in the same service, they might be, hey, this is fresh in my context, I'm also making change in the same place, it's something I might want to do. And last, what also helps is to add sort of a deadline or some sense of urgency. Is it something that needs to be done now because it's a critical fix, or is it something that can be done later this week so that people can sort of plan around it? And then what you could get is something like this, where you add a specific audience or specific team, and you add some context around it, and maybe you can also make it a bit friendly, add a bit of fluff around it, and then, there's more likely that you're actually going to get a quick response. And this actually, of course, again, goes further than just pull requests. This is actually whenever you need something from another team, maybe you need some help, maybe you need some data, maybe you need some reports. It's helpful to just tag specific people and add some context why you need it and when you need it, because then it's much more likely that you get a quick response rather than I dumped my message here and they didn't reply. And I know that in practice, still people will forget, and it's also very human. We get distracted. It's a work. Our field is constant distractions, right? There's a question here, a message there, everything, and then you're fixing this. At least I'm very bad at this. Then I'm fixing something here, and then and hey, a butterfly. And so I mean, we're still human. Feel free to remind people. Now, when people start looking at it, we're also going to get some feedback, and this feedback might, as I mentioned before, not always be as expected. So the thing is that some people simply lack social skills, so you could make them aware of the fact that the tone of voice might not be suboptimal, but there might also be cultural differences at play. So I'm from the Netherlands. We're known to be quite direct, which also means that we might sound quite rude, even though it's not really our intention to offend somebody. We're just straight to the point, which means that being aware of this. For example, I should probably add some fluff around my messages, but on the other hand, team members could also know that, okay, this is just their way of communicating, it's not something personal. And that's actually also when we talk about not taking it personal, which is sort of what being a professional is about, right? Even though the tone of voice might not be what we like, let that not distract us from what we need to do. We need to deliver a nice software here. So be patient, try to be the bigger person if you feel offended. It can happen, but let's be professionals. Now, what can also happen is the vague feedback. It's quite annoying. People simply don't like it, and they don't really give you very useful feedback. They just, Now, you have two options. The first option is to go through this trial and error phase and reread the message 20 times, trying to figure out what they actually possibly meant. Or just ask for clarification, because that's way more efficient. It also forces the reviewer that maybe was a bit too lazy to actually put in some effort on the command he placed. And you don't have to do this trial and error. It's about saving time as well. There's the endless discussions that we probably also know. We also all know the answer, that is, don't just pick your battles. But still, it might happen that two developers pick the battle at the same time. Then it can happen that you are on the 20th reply in a thread, or I don't know how many. This is maybe the point where you should realize that maybe it's better to just take this offline or in an online video call. Because it's much more efficient than this async discussion that might take 2 or 3 days and it's just causing frustration. Talk to each other. But if you do that, report back. That's also, don't report, we decided to not do it. No, we decided to not do it because of why. Because, again, future you will forget this, but future you will look back and see why did we go for this? What happened? Also, again, doesn't just apply to pull requests or commands, also goes for Slack discussion or anything which sort of the written form is also used as an archive. Now, not all feedback will be bad. Also try to be sort of grateful for the fact that people took the time and effort to go over your changes and try to sort of help you make something better. It could be that you actually learned something, or that the commands that somebody gave you new insights that make the thing better, rather than just saying fixed or ok or done or just resolving it. It's nice to just thank them for it. this goes, the friendly message goes a long way, sort of always the classic thing, but also if you say you have a junior that's just started, he finally started reviewing and he actually found something, or he raised a really good question that helped you, just thanking them or making it clear that, hey, you added something positively, is for them also sort of positive reinforcement. They're more likely to, or more confident, so that they will more likely to review again and better and spend more time on it. So that's the getting the review part. Now we're going to switch seats. Now we're going to be the one who's giving the reviews. And the first step, most important one, don't wait too long, right? The longer a pull request is open, the more chances you have of merge conflicts, or the fact that you just need to be constant context switching because maybe you're already on your third task and somebody finally started commenting on this thing. It's annoying. So what we can do, I think the most important one is take a moment in your day. I would suggest the start of the day. That's the moment where you do code reviews or pull requests. So whenever all the pull requests are open, spend the first hour doing reviews, because then you're still fresh. You don't have to constantly switch context between the things you were already doing. The other point in time is when you're picking up a new task. So there was this, in one of the presentations I visited, they talked about, well, your backlog ideally is prioritized, which means that any task that was already picked up has a higher priority than whatever task you're going to pick up. Which means that reviewing that task has higher priority than picking up a new task. Now the next thing, I also want to make it bold and emphasize it, pull requests, the code reviews are also about taking responsibility. And what you see, and what I've seen too many times, is that it's sort of more of a write-off. Okay, I'll help you forward, approved, looks good to me. When you know they didn't look at it, right? Because there are still errors in them. I'm still curious, and still my experiment to at some point just deliberately put errors in my pull request just to see if they actually put in the effort to find them. But it's also about a mindset, right? When you review something, it should be like a sign-off. You should be the co-editor. You should be the co-responsible one. So whenever this hits the fan, the people also can come to you and ask you questions about it, because you put the effort of reviewing it. You now have to understand what's going on, because that's also the first step. You can review without any understanding and just look at code style. But is that really a review? Because we'll cover that later in the presentation. That's the least relevant part of the review, is the code style, I'd say. So make sure it's like a sign-off. Make sure that people are aware that just pressing that approve button also means that we can come to you to ask questions about why this was approved, so that you put in more effort. Now, when we start, the first thing is that we start reading descriptions. I've been Sheldon many times. I admit that I just dive straight into the code, then come into this weird thing and try to understand it, and try to understand it again. And then before I start writing a message, I go back to the description, and there's the answer. We just put in a lot of effort to writing this nice description, right? So it would be very frustrating if people don't read it and go straight into writing comments. Also, if there's already discussions going on. So see what has already been written down. And this goes two ways as well. Like, we had the first bad example, which was the pull request with no description. Rather than trying to reverse engineer from the changes what the intent was, ask them to just write the description first, because it saves you a lot of time. And again, future them or future you would probably also want to have some hints there. Then I mean, you need to start looking at it, right? Where do you start? And it's always, again, very tempting to go straight into the code style things, because those sort of are like needles in your eyes at some point. But it's best to start at the top, because any feedback you have at the top, and the top design will trickle down. So you can have feedback on that constant that was not public and should have been private, or that was public but should have been private. But they probably need to rewrite it anyway if you have feedback on the functional part, or the design. And then you go to the next step, right? So first is the functionality in the right place, then is the functionality sort of complete? Did you cover all the scenarios, or the happy flows and unhappy flows? So that is sort of established, and we can start looking at the complexity, right? Is it implemented in a sensible way? Should we maybe do it slightly different? Can we do it more efficient? And then we go to the tests. And I made tests bold on purpose because, tests already during implementation usually get the least amount of love and attention, or at least less than they should have. And you see that even more in reviews, right? They are alphabetically sorted usually in pull requests, which means that they're at the end, so you already put a lot of effort going through the implementation. And then, the tests, yeah, I mean, it passed, it should be fine, right? We sometimes tend to skip it. It's sort of frustrating to also have to go over that part again, which, I mean, it's just tests. But the problem is, and I've introduced many bugs just because tests were not complete, right? The missing assertion can be an opening to a plethora of bugs. So try to be strict on the tests as well. Are all the right things asserted? Maybe they missed some parts. Maybe they missed a certain flow. I know it takes a bit more effort, but trying to understand the test as well can be very helpful. And making sure they're right in the end will benefit you as well, as the bad test suite will negatively benefit you. And then last but not least, we can have arguments about the style and documentation and all the minor things. Well, I mean, arguable right, documentation is still important, but if there's a typo in it, we can do that at the end when we're for sure that all the other things are right. Now, there's a lot of tools available to help you with reviewing, and I think I already mentioned in the beginning, there's the version control system. So what I want to quickly show, the example on the top left here, this is, for example, in GitLab, you can have inline code coverage. So this means that this line is not covered. So who here uses inline code coverage in their diffs, in their review systems? Okay, less than I would have hoped. Because why? Why is this so useful? Now, ideally, when reviewing, like we just said, we also check the tests, which also means we should check whether it's even covered by the tests. And how do you do that if you don't have this in diffs? Then you have to probably go to the code coverage report and then sort of keep them together with the changes and sort of see, okay, this was covered, this change was covered. This is really painful. And I found when I introduced this, I found this so useful because it's so easy to quickly spot parts that were missing, but also dead code as well. When they were like, somebody was writing a solution, they added some methods, then decided to go for a different solution, and these leftovers were there. And obviously, because it's dead code, it's untested. So I asked the question, hey, why is this not tested? And then it turns out, oh, it can be removed. So it's a really nice hint. But there's more tools available. You can have Sonar integration, and this doesn't work just for GitLab, the code coverage thing. I know that Azure DevOps and Bitbucket, I think, also support this. And if not, there's still the best tool to review, which is your own editor. So suppose this is the change I more or less made. I introduced an if check that is an early exit, and I changed the constant into something local. And usually, when you look at a div, a simple div, this would sort of look ok. Yeah, doesn't look too weird. But if you then open this in your editor, where you have a much broader context, you immediately get a lot of hints. Well, the first one already, well, you can see it. I have this thing. The unused constant, right? Why is this still there? We can immediately maybe ask them if it can be removed, or you see the yellow thing. So dot equals, well, maybe IntelliJ has a good suggestion. In this case, they probably will suggest to use is empty, or the code coverage. So maybe you're not able to set it up in your VCS tool, but you can still have it in your editor. You can run your test with code coverage in most cases. And then you also have your answer on which parts are tested or untested. And most tools offer you to sort of, if you check out a branch locally, you can also immediately see the parts that were actually changed, highlighted already. And besides all the other obvious advantages, like it's easier to navigate around and to quickly see which are the usages, how is it used, because just from the div, it's not really sufficient, I would say. And I know that most tools like GitLab and GitHub, for example, they often offer online editors, but it's still not as well done as your own editor, or IntelliJ in this case, or in my case. Now, we've looked at it, we know sort of where to look at it, how to look at it. Now we will find things that we may or may not like. And there's some things about a good command in the tone of voice. So what you see here as an example, you chose the wrong framework, use X that is actively maintained. It looks innocent, but, well, maybe not. The usage of you should have, or you're not supposed to, or you forgot. It feels like a personal attack in some cases, or it can be interpreted as that. Whereas if you use the word we probably chose something. And I know that we didn't make the change together, but we are, as a team, working on this, and we are together in trying to make something nice here. And we already sounds a lot less, offensive, I would say, or at least in the other way, it will make people less defensive if you go for the usage of words like we. And the same also for statements versus questions, right? I said you chose the wrong framework, but if you turn it around and make it to a question, first of all, you don't risk being wrong, right? Because, I mean, maybe they had a really good reason and you just look like a fool because you make this bold statement. Also, it's much more friendly. And again, also it can give them, so they will think about it. Why did I choose this framework? And either while writing the answer, they come to the same conclusion that you had, which is really helpful because then, right, okay, you're right. Instead of going sort of the defensive mode into finding reasons why you're wrong, they might come up with the solution. Yeah, I lost my train of thought there, but people are more willing to cooperate if you make it a lot friendlier. So if I would go for this, why did we choose Y? I understand that X is more actively maintained. We can still add our suggestion there, but we sort of leave it open for the person who made the changes to come up with reasoning. And maybe they think you have a great idea, but then at least they're more likely to start with thinking along rather than thinking against it. Then what I also mentioned is the specific part. We already had this vague feedback. We, of course, don't want to write vague feedback. We want to be specific, so try to stay away from words like this or it. Also because they are usually a great cause of ambiguity or multiple interpretations, because this might refer to 3 things that you mentioned before, and which one was it exactly? And what you can do to sort of make sure that this is not possible, always reread your comments. Like write once, read many times, read it first, and then maybe you come to the conclusion that there's actually many interpretations possible. And if there's more than one interpretation, it also means there's a likeliness that people go for the wrong interpretation and waste time there. Even though rereading the comment might be 10 seconds, trying to interpret the thing and trying to interpret which thing was meant was maybe minutes. And it's micro-optimization, but it makes it much easier to work with somebody. And it's also very easy to say that you don't like something. It's much harder to come up with an actual alternative. And maybe you come to the conclusion that there actually is no alternative when trying to figure out the alternatives. So try to see if you can help people along as well, rather than just saying that it's not good. Now, one of the cool features that I really like about VCS that I see used too little is the suggestions. So what you can do if you have a div, is you can select the lines you want to see changed, and then there's this suggestion button. In GitLab, you add a command and you can use this nice button, and it will already put the lines in there, and you can make inline changes, and it will then show up as a div like here. It's a minor optimization, but the advantages are twofold. The first side is that it's immediately clear what you meant. There's no other interpretations possible. Whenever the reviewer applies it, it's immediately applied like the way you want it to, and that also means you don't have to go back and check if it was done correctly, because it was immediately done as the way you wanted to. So it sort of saves time on two sides here. The one caveat is that, of course, if you suggest to remove a class file, of course, the import also needs to be removed. So be mindful about the fact that there's, of course, more going on, and you can't always use it. But for Javadoc fixes, it's perfect. If somebody has some Javadoc suggestions, click Apply Suggestions, saves you some time as well. Now, there's one more thing, because there's also conventional commits. I mentioned before, I also came across something called conventional commands. To be honest, I think it's a bit extreme, but it's also kind of nice to experiment with. So I tried it for a while, and I kind of liked it, because it sort of structures the way the reviews look, and you can immediately see if something is like, oh, this is a suggestion, oh, this is an improvement. I think the biggest takeaway is mark things that are relevant and not relevant, or specifically, if it's a nitpick, mark it as a nitpick, so that it's immediately clear. Okay, this is not super relevant, do with it as you like. We could make the deal on the team, like say, okay, if it's a nitpick, it's up to the person who makes a change to decide whether or not they're going to use it. They're free to resolve it themselves, and it's up to them. It's just a simple suggestion. Now, we had a lot of commands. There's one more thing. We also did it with receiving commands. Try to also find something positive, because it's a place where there's a lot of negative commands, or things that could be interpreted as negative. You basically hear that you missed things and you could have done better. But you also want to hear the things you did well. And it could be as simple as, oh, you wrote a really nice test suite with somebody who used to be really bad at writing test suites. But also in any way, maybe you like the feature, maybe you like the fact that you didn't like the feature and you're very happy that somebody else actually took the effort of writing it. And there can be many reasons why you like something. You learned something new. I didn't know this method invocation of this framework. Just write it down, because again, friendly message goes a long way. It boosts the confidence, and especially in what you see in a time where there's a lot of imposter syndrome, we all think we can do better. Compliments really help in boosting confidence and making people more confident about the work they do. Right, 10 minutes. Great. So this sounds good. Let's go about one part that I didn't fully cover yet, bike shedding. Bike shedding, this is a very typical Dutch thing, of course. Also known as the law of triviality, is about spending a disproportionate amount of time on the irrelevant parts of whatever is going on, the trivial issues. And the story comes from a committee that was supposed to discuss the power plant, but spent more time on discussing the bike shed of the office, because that is easier to grasp, right? If it's a red color, I don't like red. I mean, the power plant, I have to think way too hard about that. And in practice, you could argue that things like this could be considered bike shedding, whether you use equals an empty string or whether you use is empty. It does the same thing, right? Whether you go left or right, it does the same thing. And all these small commands, tiny things like, hey, should we go A or B? They add a lot of noise. And the problem with this noise is that it sort of distracts us from the actual problem. Also, when looking at it, right, you have the people that review the code style issues and they think, okay, I found 5 code style issues. Sure, I did my job. Approve. But also, yeah, just in general, it's a distracting. And now I want to go over a set of tools. So I don't have time to go in depth, but I do have time to mention them at least, that help us automate all these discussions away. And the first one I want to go over is Error-Prone. Error-Prone is made by Google. It's a static analysis tool that catches programming mistakes at compile time. And the nice thing is that it also suggests fixes for it. So it has sort of a before and after situation where you can automatically patch your code, which is super useful when you introduce this in your team. Then there's, I added the heart for Picnic. Picnic is a Dutch online supermarket, and they extended it with another big rule set. So they had a big rule set internally of all the things that it could do, and they decided to open source that. Now, what does it do? So one of the things you can have is discussions about how you do null checks in a list. So here I filter a list, I check, I want to get rid of all the nullable addresses. The other way you can do this is by using this objects non-null thing. It's technically less characters, you might like that one, or somebody might like that one. Now we can have a lot of discussions every time in pull requests, like, you should have used this one, or this is our company standard, we should go for non-null, this is our standard, why do you do this? That comment, if I can automate that away, I don't have to waste time on it. Or big decimal dot value of 0, you could argue this is suboptimal, why not use this? But these are minor optimizations, but they are still useful. So if you can automate this away, it's really nice. And so it allows you to do, if there's multiple interpretations possible, to just pick one. To give you some more examples, one that I really like is the logging. So in Java, the string format of Java uses %s, and the loggers always use the curly braces. And it's often, or it happens at time where you mix them up. And this tool will tell you, hey, this is the wrong one. This is for logging. You're using string formatting. You probably should use something different. In this case, it doesn't have a suggestion because it needs to really understand what's going on. Or assertions that are broken. So who here sees what's wrong? What is wrong here? Yeah, so this doesn't do anything actually. Because, I mean, it compiles, but the assert that from Hemcrest and assert J needs a dot is equal to or is true at the end. So in this case, it was assert that Boolean. In this, the most simple way to write this should be is true at the end, and then only then this assertion will do something. And it's so obvious, but it's also so hard to miss if you're just doing a review and you're going over 20 assert statements. How likely are you going to spend that much time on each assert statement? So there's a lot of these fixes. But it's also good to know that it's also very biased towards certain standards. So Picnic is very towards immutables, to using Spring Reactor. So they have a lot of rules for that. If your company doesn't use that, disable those rules. Also, because it's compile time, we, for example, use Lombok a bit too much, or unfortunately we use Lombok. And especially if you go into super builders, those are the nasty bits, you might have some issues with them. You have to go over this. And then eventually, it's a short investment, but then eventually it will pay up. Another one is Open Rewrite. So anybody here who by hand still needs to migrate from JUnit 4 to JUnit 5 or wants to upgrade from Java 17 to 21 or Spring upgrades, don't do this by hand. Check out Open Rewrite. It's open source, and it gives you a lot of recipes to automatically upgrade your code. And why is this relevant in the context of pull requests or code reviews? Is that what you often see is that you have still a Java 17 switch statement, but you're already in Java 21, and people will start asking, oh, you touch this class, can you please also change this? Get rid of that noise, just do the whole thing at once. Another thing, formatting. Formatting adds so much noise to the pull requests, especially because some people do, some people don't. So the starting point is have a consistent formatter, then have everybody use it, and then you come at the point where I also was, is it wasn't enforced. Which means that whenever I was reviewing a pull request, the first thing I did is check it out locally, do a diff against development, run the formatter, paste the list of changed files, copy the list of changed files, paste it back in the pull request command. It's wasteful, but if people don't want to review, that's sort of the place you end up. Or you automate it. Now there's different ways to do this. The one I like most, Google Java Format. So Google Java Format is a very opinionated code formatter that implements the Google Java style guide. There's no other interpretations possible. There's only one interpretation, that is their interpretation. I think there's only one option, right? There's tabs or spaces. That's effectively the two things you can choose, and that's where it stops. And I know this can be very painful because you need to get used to a new situation, and it's also painful because if there's only one way, there's also a chance that in certain situations it might not be the best way. But there's no room for discussion. So it takes some time to get used to, like it always does. But if you bite the pain, then you don't have to argue about, oh, please add a line break there. And a tool to automatically apply this is Spotless. And the nice thing about Spotless is actually that it doesn't cover just Java, it covers a lot of languages. Because we all know that our projects are very multi-language. There's SQL files in there, there's configuration files in there, there's JSON files in there. Format all of them, and then you don't have to be bothered about discussing it. I'm going a bit faster because I'm running out of time, but the check style. So I was unfortunately in a situation where I couldn't convince my team to use Google Java Format, so the second best solution was to just capture the formatting that we had, which was IntelliJ formatting in checkstyle rules, so that at least we could enforce it, like where the line break should be, whether the braces should be there, the ordering of methods maybe, constant naming patterns. Checkstyle can also be really useful. Then there's Arch Unit, something that also a lot of people don't know is it's a library that can use to sort of enforce architectural rules based on, for example, packages. It has a really nice DSL. For example, what I can do is I can define packages. So I say this layer controllers, which is defined by this package, should not access these or should only access these layers. So the very classical thing, like your controller should not directly access your repositories, or your repositories should definitely not be talking to your controllers. Capturing this in these kinds of rules, also if you have certain guides on where to put which information with which names, it's really nice to automate it. One of the things that I really like, for example, is an easy rule to consistently name interfaces. You can do it in many ways, right? You can put an I at the beginning, you can put interface at the end, or you can put impl after the implementation. Honestly, it doesn't make a difference, right? I don't care as long as you do it consistently. And this is the way to sort of make sure that's consistently without having to manually check this. Or you can do the same thing with controllers. They should be annotated with a certain annotation, like secured. Now, when you start with this, for Arch Unit, there's a large set of predefined rules that already helps you capture the common mistakes. When you start using Arch Unit, create a shared module with all the rules that are there and use them across all your different modules so that you're sort of consistent all over the place. Now, if you like these tools, what you want to do is don't just throw them all in the standard build and then your team will be pretty overwhelmed. Start small and create sort of sample merge requests or pull requests where you discuss each different change. Like in the case of error prone, I created an example pull request with all the changes applied, and then I added commands, links to the rules, like why did it make this change, because actually there's a lot of documentation on why certain ways might be better than the other. So centralize it. Now, to conclude, write descriptive pull requests, review them yourself, be specific in your communication, and also be friendly, try to find the positive things, make people feel a bit better. Use the VCS features and your editor to help you review, and stop with bike shedding and start automating. So, thank you. So this is an overview of all the links. The presentation will also be published online, so on YouTube it will also be, you can take screenshots of it. You can also, people are done with sort of taking pictures, again, it will also be online. please, if you like the presentation, leave a rating. I want to thank you everybody for being here. I don't have a lot of time for, or actually I don't have any time for questions, so I'll be out in the room or in the hallway if you have any. And if you have questions, you can reach out to me. I have a GitHub profile. There's Twitter, Blue Sky, anything is already on there. Thanks again.